One more chair. Okay. Everybody has a seat? Yep. Yeah, good. Oh, yeah, right. Okay. Speak for yourself.
Or you sit there, and if you sit there, I'll sit there. Can you sit?
Yes.
This is yours?
No, I mean.
You okay over there? Okay. All right. So welcome to the lab. So today we're going to do the measurements for the actuators. Okay. So we have the pneumatic actuator and the electric actuator. So just by looking at this station here, can you differentiate between the electric actuator and the pneumatic actuator?
Yes.
So which one is electric, which one is the pneumatic?
The one with the piston is the.
You have colors here, so can you
The
can you
black
use
one
colors?
is electric,
Yes.
and the one with the blue tube going in is
It's green.
Fantastic. Okay. All right. So the purpose of the lab is to get you to know the properties of the pneumatic actuator and the dynamic of the both actuators. Okay. So you have the electric actuator. So in the manual you have the design, the drawing. So you have the motor here. There's a motor. Here you have the gear and the clutches around here, and here you have the piston. Okay, and here is the electric wire to power the motor. Okay, so and this is the fastening port to hold the electric motor in place. Okay, and this is the pneumatic actuator. Okay, so these are the tubing that we use to channel the compressed air. So these are the valves. This is the entering valve. Okay, so we pass the entry air goes in here, and it will pass through this separated tubing. So this one will control the extension. Sorry, this one will control the retraction, and this one controls the extension. Okay, and this is the compressor over there to supply air to our pneumatic actuator when we'll be using it. Okay, and this is the regulator. This is the regulator to regulate the compressed air that will be passing through the pneumatic actuator. Okay. Okay, and this is the power supply. Okay, and we will have two people volunteers to help to operate this. So please volunteer yourselves. Okay, so it's not anything tedious to work here. It's just you will be controlling the voltages that we'll be using for today's experiment, and you will be the person who will be reading the values of the currents, and the second person is to be writing down the values. Okay, when we get there we will explain further. Okay, and all right, so this is the computer. We'll switch it on. Okay, we'll start today first with the electric actuator. So you can now volunteer two people. I'll give you the table of the values of the voltages we'll be operating with, and then it's pretty much clear what you need to be writing down. So the person writing down will provide the values of the voltages to the person operating the power supply, the voltages. So when we do the extraction, you write the values of the currents for the extraction and for the retraction, and you also obtain the velocity values for the extension and the retraction and the displacement. Okay, for this velocity and displacement, we're able to save the file in the system. However, you also manage to put it down here just for purpose of the standby experiments that you see yourself already in the lab, so you try to make some evaluations presently. Okay, and for the currents, so the person will be reading the values of the currents, then the person writing it down, So the person will jot it down in this paper. So this will be for the electric actuator, and the next one will be for the pneumatic work that we'll be doing, and then the next one will, the third one will be the bandwidth. So we'll be doing the exercise for the bandwidth, okay, for particularly for the pneumatic actuator, okay. So I'll two people, please grab your seat. You can sit close by here. And I'll switch on the system here. So we have the lab view that we use to visualize the performance of the actuator. Okay. Okay. You want to write down or you want to operate it? Okay. Someone writing down should come here because you managed to read the values. So we have lab views for electric actuator and pneumatic actuator. We start with the electric actuator. I'm switching it on. Okay, you can go a little bit there. Okay, the lab view is coming up. One more thing I'll need to mention that we have the potentiometer that we use to measure the velocity and the position of both actuators. Okay, so at this moment it is being attached to the pneumatic. I will switch it to the electric as we are starting with the electric first. Okay, and as the potentiometer is attached to the piston of each actuators, it moves alongside with a piston when it is extracting or retracting, okay? And then the values are being shown in the system here, the position and the velocity in the lab view application over there. Okay, so this is a potentiometer. I'm switching it to the electric actuator, attaching it to the piston, okay? To the piston rod. Okay, the lab view is on. I will switch on the supply. The control here is sensitive, so you have to manage. So if the values that you have on the table, it's not right quite to the value here, you can tell her the exact value and she can rewrite.
So I'm setting here 10, 20, 26, and then 30
yeah. So we are both doing both the unloaded motion, loaded work of the electric actuator and loaded work. So we have 12 kilograms of the weight here. Okay, so when we work with it, we'll have to attach it to the piston rod. Okay. All right. So in the manual you have the descriptions of this application here. So for the purpose of writing things down, I'll just explain one more time. So this is the displacement. Okay, you'll be seeing the plot of the displacement here, and here will be the velocity. Okay. And here you will be seeing the position of the piston, and here is the velocity value, okay? Okay, I'll be the one operating here. You'll be writing down, and he will be operating the power supply. Any questions at this moment? Okay. And you can actually stand at any time you want to see what is going on. It's no problem. If you cannot see from sitting down.
Which part am I filling in? Extension for?
Yeah, so extension, we are doing unloaded first of the electric actuator, okay? So I'll make a first movement so you will observe what is going on there first. Okay, I'm not saving anything here. We'll have to log a file. So here, You can stand up and see the movement of the electric actuator, how it is moving, okay, slowly, okay. This is the extraction, and you can see here the displacement window. So I just paused it a little bit so you can see on the screen here. So this is the velocity, you can see it's on around 10 millimeters per second, so it's on a positive side, and you see the elevation of this actuator in the positive direction, okay, the displacement. And when you retract it, okay, then you wait for it to. So when you retract it, you see this velocity is on a negative minus 10 millimeters per second, and then now this motion here is now coming down compared to when we extracting the piston. So basically, it's a linear motion, as you guys wrote on your task. Yes, it can be rotary or linear motion of the piston. So here we have only linear motion of our actuators. Okay. All right. So we can do the measurements now. So I will create a folder. So I will turn this on now. You have to start your measurement. So you have 10 volts there. Okay, so you keep track of this value, the current, and she'll focus on this one. So she'll grab the measurements here, but
I'll remember the current.
Yeah, and give it to her later. Okay. All right. So let's go for 10 volts on loaded work. Extension. Okay. And the retraction. Remember the volume? Yeah. Right, so what was the value of the
Extension is 0.26, retraction is 0.24.
I can't take the displacement and velocity together though.
Okay, let's do that again without saving it. Okay. Now, okay, extension. So it's about 121.
This is velocity now.
Okay, and the retraction was okay. 40 something. Okay, you have it already. All right. So we have.
No, I mean like Tess last year gave us an email like a
So we do.
we can check right now.
Yeah, the potentiometer is connected to the so it's the potentiometer measuring the displacement and the velocity. Okay, so we have 20. Okay, I'll change this. Just let me make sure the one we have is right.
Or you can, but no, you can't.
I'm not allowing anybody else to say
Okay, so that one registered. So we now go ahead. Okay, ready?
No.
Yeah. Okay, we're doing the extension. So we switch to voltage. voltages
This way.
20 volts, okay, and then we have done the extraction, and we're doing the
Current was 0.33.
okay, and then the retraction now.
I think that's all those right.
Current was 0.29.
No, just be
Okay, that's done, and we move to 26.
I'm not allowing anybody else in my disaster.
Now 26. Okay. Extension.
Current was 0.36.
Okay, and retraction. You able to grab it, or I can do that again? You okay?
Current is 0.33.
Okay, and next. 32. We have 32 here.
Doesn't go any further than 31.6.
Okay. Yeah, that's true. Okay, we'll do this 31, okay? And also here we'll be 31. You okay over there? And we can start this, okay? Extension.
Current is 0.30.
I don't know.
I hope they're foldable.
Don't know.
They're not. Okay, so they're worth.
Yeah.
Oh, want me to do this?
Okay, so we'll do that with for the retraction. Okay.
Going back to Virginia.
Current is
All right.
0.38 and 0.35.
Okay, so now we have finished the unloaded work. Now we'll switch to loaded work for the electric actuator. Huh? You want to write down?
No, I want to be the low.
Oh, it's 12 kg, so it's left for the instructor to do this part, okay?
Let's go and do this.
Alright, so I'm attaching the weight to the piston of the electric actuator.
I bet you this list does not exist in your premises.
No?
After this, yeah.
Attached, okay?
We're doing it too, right?
Yeah, so I'm lowering the weight.
Panics of two. So we have two.
Okay.
Watch out.
Alright, so we now loaded the piston with 12 kg, and then we'll repeat this now.
It has to be.
Maybe we'll start from 31 up.
Oh, from 31. Oh, okay. So.
Oh, no, it's fine, from 10. Let's start from 10. So, ready to read the values?
Yes.
You can see it's more slower
Yes.
than when unloaded. Still linear motion.
The current value kind of changed to sort of 0.30 and ended up 0.36, so just take the average there.
Yeah, you're taking the average.
Okay.
So we're doing the retraction. grab it, or we can, you want to do one more time? You got it, okay.
Current was 0.33 on the extension, 0.72 on the
No.
extension.
Try.
7.
Oh, 26. Ready? Standing.
Current was 0.42.
And refraction for loaded work, 26.6 volt.
Current was 0.78. Current was 0.45. And current was 0.81.
All right.
Can you
Stop. Okay, so we have it. So guys, we'll take a look at the values that we have. So if you can come closer. So as you can see, the current, the current when we are retracting is increasing. Okay, for the unloaded, and the current for the loaded one is higher than the one for the unloaded work. Can anyone tell us the reason why the current for the loaded work is higher compared to the loaded work?
Because it needs more power.
Okay, right, that's correct. In the back of this, you'll be taking this home. This is the reports requirements that you'll be making based on the measurement that we did today. Okay. All right. So that is it for the electric actuator. So based on what you have seen here now, in what possible applications that we can use this electric actuator?
Flight controls.
And yeah, flight controls in what system for it to function? So flight controls.
To extend or retract the
The
flaps and
okay.
drivers. And then
On relatively
Rudders
small
and-
airplanes, I'd say. Like,
Landing.
The fins, you can use it to control the fins, the flaps of the airplane. Also, you can use it for antennas, align the satellite antennas position. Okay. Any other applications?
brakes, landing gears. To extend.
Okay. Yes. Okay, that's correct. And any other applications?
No.
No, okay. All right, so this is also in your report requirements, so you can get more applications based on what we have done today. All right, so we'll switch to pneumatic actuator. I will close the lab view for electric actuator and open the one for pneumatic. So you still have this paper.
should I turn off this?
No.
Cannot speak, but he can imitate people.
Okay, I will reattach the potentiometer to the piston of the pneumatic actuator.
No, but if it is what you get on board, but so far on board you got like these fruit jam buns, and now they're degraded into waffles.
Okay.
The inflation is going on.
What is that?
It's the
Okay, so first we just test the device. you can see the movement. So because this one is a little bit pressurized. Okay, just a moment. We need to push in. We need to apply the compressed air in there. Okay. Alright, so we have applied the compressed air into this regulator. Okay, so when we operate the system, it will channel the compressed air into this valve here and control the piston. Okay. Alright, so just to show you how this works, so you can see for now it's going to retract. At this moment it is on extended position. It is on automatic, okay. Okay. That was the retraction, and this is extension, okay? Alright.
Yeah, I mean, I don't have any current here yet.
I mean, if
So you don't operate anything there, we just need to do the displacement and velocity. Okay, so we're working now with the pneumatic actuator. Unloaded work is at this moment on extended position. I'll retract it first.
Vienna, with your passport.
Yeah, this is my passport.
Oh, yeah.
Okay, so it's working. Alright, so now ready to take it out.
Yeah, I'll read velocity.
But you lose on your laptop.
Okay, extension.
First day, first semester.
In Vienna, you lose your
Hold
laptop or no?
No,
Oh.
I didn't take it. Otherwise I would kill myself.
Pitch 10.
Okay, extension was about 720.
You looked at yourself.
The retraction was about 706.
Oh wait, where are you at? Wait, the same road.
Okay, you have it? Yep. Alright, let's move that and then we'll do for the loaded work, okay?
Pablo did not change clothes. He's even wearing the same hoodie, I think.
He looks the same as he was now.
Yeah, Papa.
You've been like this for like 7 years.
Kinda, yeah.
Yeah.
I've only grown like a little bit.
Are you sure?
Yeah, I mean almost
He
everything.
showed us a ninth grade picture and he looked the same. You showed us a ninth grade picture and you looked the same. How?
At least one person got it.
I answer very much.
I had very different hair when I came
But you weren't right because I think this was the first day and
I was not
I got myself into these things.
Yeah, extension was about
Why
600.
is this bigger to tuna?
Retraction was about 600.
He's right. Even if it's perspective, it's not supposed to be this big compared to tuna.
Okay.
Tuna's head is so small.
He got grey hairs now.
Raj?
Roj,
Fits the personality.
He gets grey.
Alright, so that was that. Alright, so guys, interesting part of the lab, the bandwidth we are doing now.
Don't you see?
It's the same. It doesn't get this right.
Okay, so we'll be doing the bandwidth of the pneumatic actuator. Okay, so it's important to get the values of the pneumatic actuator. So please listen. So bandwidth is the range of input frequencies over which the actuator follows the input signals without too much delay, too much lag, or distortion, or what else? Weakening. Okay. In a technical format, okay, let's use the second order step input function to explain this bandwidth. Okay. Step input response. So let's say this is your step input response. Okay. This is the in frequency domain we are drawing this. All right. Guys, are you guys okay? All right. So here you have the resonance.
Inhibition.
Okay. So you have the here you have the resonant peak. Okay. This is the resonant peak, and here you have the resonant frequency at which the resonant peak occurs. Okay. And here you have the unit gain. Okay. This is the unit gain, and so this is the unit gain. So the bandwidth, in technical term, the bandwidth is the specific frequency for which the actuator drops to 3 decibels. Okay, usually 70% of the original magnitude amplitude of the actuator. Okay, so when you have this drop of 3 decibels, okay, and of 70% of the original amplitude of this pneumatic actuator. So please remember it's 200 millimeters, okay, and this will be the bandwidth, okay. Sorry. Bandwidth, okay. So what we want to get here is maybe I'll give you the characteristics of the amplitude in a sine wave form. So when you will be doing the measurement, you will be seeing such a plot, okay. This is a time domain. So when we are going to increase the frequency of this actuator, so the values is on this table. So we start from 0.5. So if we increase let's say you're starting from 0.5 hertz, you will have a sine wave like this. Okay. Okay. This is it will reach the maximum amplitude and also the lower amplitude. It will be even. Okay. Okay. Based on experience and measurement that we've done, this value is consistent up to 2.2 hertz. Okay. So bear that in mind that up to 2.2 hertz we can have this maximum and minimum amplitude even. And when we increase the frequency from 2.5, we start to have some narrowing, compression of this sine wave. It could go like this, okay? The compression will come like this, okay? And if you increase more the frequency, you can start having this V-shape compressed sine wave. And to a moment, you will start to get this amplitude not even reaching to the maximum and minimum value. So it doesn't matter where you start. It can start from the bottom, yeah, to reduce. It can also start. It can also start from the top to reduce. It's not going to reach the maximum amplitude. And also you can have situation where either will not reach the maximum and minimum amplitude. Okay, so we'll be applying the frequency one after the other. Okay, we'll be saving that in the system. But however, what you are interested is to get in the the values. So this will be your applied frequency in hertz. You get your maximum amplitude and minimum amplitude. Okay, minimum. Okay, you have to get the difference of this amplitude. Okay, that is maximum minus the minimum. You get it, and then you get the amplitude percentage. Okay, so when you have this 70% of the amplitude is around 210. Okay, so and that's the 70%. So when you get the percentage to 70%, that's when we are stopping this increment of the frequencies. Okay, so this is basically the characteristics. So that is what I want to show you, because when we start the movement here, there will be no time, or it is really fast to see what is going on. So bear that in mind. What we have shown on this table on the whiteboard. So when you see it here, so you will not be surprised. Okay. All right. So let's push on the air a little bit, because as we will be changing the frequencies, the air will be reducing, and we'll have to apply the compressed air so that the pneumatic actuator will work. Okay, so yes, you'll be reading the values here. Okay, if it is not conducive enough to read it from here. So the original amplitude is 300. So that's when you are doing the percentage of the amplitude. So you'll be doing the difference of the amplitude divided by 300, and this is where you'll be getting this percentage till you get 70%. All right. So let's start with 0.5. Let's increase it. Okay, we are switching to automatic.
What?
And now we are starting. Okay. Okay. Stopping it so we don't have to put a lot of air. And now it will be 1. Okay. One, and this will be 1. Okay. You can see it started to be faster. We increase the frequency. Okay, we still have some air to move to frequency 1.5. You can see the time wave in this moment, okay? Okay, and now it will be 2. Okay. Okay, we're saving. So it started to somehow look like a V shape. Okay, so the most important part is we know that from 2.2 is the good movement, effective usage of the electric pneumatic actuator. So from 2.5, so if we can manage to write it down, so we can see, we don't need to calculate the amplitude, but we can do the one from above 2.2, okay? I think we're doing 2.5. Okay. actually. .7, okay. Okay. Let's get that. Good. Yeah, 2.5. They are not even, okay, and the sine wave is more compressed. Okay, and 3.4.
Kind of random.
Okay, so pretty much that will be it for today. So what you need to put in the report is in this information here. This is just to show you how in the beginning, the measurements we did for the electric actuator. This is the, maybe I will show you now, how the file looks like. Okay, this is this. Okay, so you have velocity and displacement. Okay. So please make sure the time has to be in seconds if it is based on the values that you see here. So please make sure it's in seconds. Okay. And the report, you want to do it in one group, right?
Yeah.
So you need to put your names.
Okay, I hope you don't mind for me to say that I don't decide. Yeah.
Only merge.
Oh.
Enjoy.
Thank you.
Whatever you find there, enjoy it.
Okay, so please write your names.
There won't be space for all of us. We're 14. Do we just write on top or on the bottom or the?
Yeah, right.
Yes.
So guys, the plot of your bandwidth should look something like this. Okay, you'll be plotting the amplitude against the frequency. Okay, just more or less this is how it should look like.